once again, and welcome to Pankaj Sir's Echelon Tutorials. And today in this session, we are going to continue from question number 6, because in the previous video, we did till question number 5. Okay, and this is all on basic maths. Okay, and this is for IGCSE 10th grade, right? Now, question number 6 says that you have to find out the LCM. Now, let me choose a, yeah, we go for this. The question says, question number 6, find the LCM of the following. So question number A is, sub question A is 42 and 60, B is 66 and 72, and third one is this. Okay. Now what I'm going to do is, I'm going to show you on GDC, as well as I'm going to show you on this screen also how to do it manually also, this LCM questions. Okay. So the first one is 42 and 60. So let us go for that. So for that, you know what we will do. First, I'll show you how it works manually. Okay. So manual means without calculator, right? So one second. Yeah. So here we go. What was it? 42 and 60, right? So LCM of 42 and 60. If you want to find out this, there are many methods of finding. So first I'll show you some of the manual methods, and then I'll show you the GDC method as well. Okay. Now suppose you want to find out the LCM of 42 and 60. What you have to do is, you can write this 42 and 60 in this way and put a L bracket like this. Okay. Now start with a 2. Okay. Now 2 into how much is 42? 2 into 21 is 42. So write 21 over here. Then 2 into how much is 60? So 2 into 30. Then again a L bracket. Now again see if this both number goes by 2, or even 1. If it goes by 2, you have to go by that number. So this 30 goes by 2. So I'll take a 2 over here. 21 is not divisible by 2. So I'm going to write 21 as it is. But this 30 is divisible by 2. So I'll write it 15. Right? Now I can see that 21 and 15 both are not divisible by 2. So I'll go to 3. Now 3 into 7 is 21, and 3 into 5 is 15, right? Now after 3, now again this 7 5 doesn't go by 3, so I'll go to 5. Okay, so 5, 7 will not be divisible by 5, so I'll write 7 itself, and this 5 will be divisible by 1. Okay, so 5 ones are 5, right? Now last remaining is 7, so I'll take a 7 over here, and 7 ones are 7, and this one I'm going to write as it is. Now you can see here, okay, whatever I'm getting, that is 2 into 2 into 3 into 5 into 7. This is nothing but the LCM of 42 and 60. So this works out to 2 2s are 4, 4 3s are 15, 4 3s are 12, 12 5s are 60, and 60 into 7 is 420. So this is the LCM of 42 and 60. This is one of the method. This is known as long division method. Okay. One more method, let me tell you, let us discuss. 42 and 60, you have to find out prime factors. Okay. So prime factors of 42 will be, start with 2. So 2 into 21 is 40. Then 21 you will go for 3. 3 into 7 is 21. Okay. And then 7, then this will be 7 into 1. Okay. Now, once you get 1 over here on this branch, you have to write this as 2 into 3 into 7. So these are the prime factors of 42. Same way 60 ka start with a 2, so it will be 30. Again 2, it will be 15. Again 3, it will be 5 over here. And again 5, and here you will get a 1. So the prime factors of 60 happens to be 2 square into 3 into 5. Right? Now, once you get the prime factors of 42 and 60, what you have to do is, you have to take the common factors, common prime factors. So that is 2. One by one you have to take. So first I'll take 2, and I'll check which has the highest power, whether 60 has higher power or 42 has higher power. So I can see that 60 has higher power for 2. So I'll take LCM as 2 raised to 2. From this 2, I'm going to select 2 raised to 2, not 2 raised to 1. You have to select the one which is having highest power. Then next is 3. 3 both are having the same power, so I'll keep it as 3 only. 5 is not common, so uncommon I'll take 5. Another uncommon I'll take as 7. and then I'll multiply out all this to get the LCM. So this will be work out to 2 2s are 4, 4 into 3 into 5 into 7. So 4 3s are 12, 12 5s are 60, and 60 into 7 is 420. So again, I'm getting the LCM as 420. This method is also okay. This method is also okay. Got it? So these are the two methods mostly we use to find out the LCM, right? This is long division method and this is known as prime factorization method. I'll write the names of if you want. This is prime factorization method and this is a long division method. Okay. And the third case is using the GDC. So if you want to use GDC, I will show you on my document camera. Yeah. Now here you can see my GDC. That's TI car and Inspire one. Okay. And CX2. This is the one I'm using. So, okay. Right. So yeah, can you see on the screen? So first what I'll do, I'll go on to the calculation. Okay. So calculation I'll do okay. All right. Okay. Now can you see I'm getting this calculation over here? Now what I'll do is I'll come down or I'll rather take a new page. Okay. Yeah. I'll go to first new, and in new I'll add a calculator, the first one. Okay. And here I can do that LCM. Okay. Now for LCM, what you have to do from this alphabets below, you just type on for LCM. Can you see LCM, right? On the screen, you will be able to see. Now I would like to make it a little bigger. Okay. So can you see LCM you are getting? Then you have to type for the bracket, parenthesis. So here you get parenthesis. Okay. Then you have to put the two numbers whose LCM you want to find out. So what was our question? It was 42 and 60. So let me put 42 and then comma is over here, and then 60. Okay. And then close the parenthesis. Right. This is the way on graphic calculator you have to try to find out LCM this way. So you have to type in LCM, put the start with the bracket, then write the two numbers whose LCM you want to find out with a comma between the two numbers, and finally complete the bracket and enter. Okay. Now can you see the answer you are getting here as 420? So using a GDC, if you want to find out the LCM of any two numbers, this is the way you have to find out. Okay. Fine. Now this is escape. Okay. So let us go to, now this I will cancel out. Now let us go for the next one. Okay. Yeah. Fine. Okay. Now let us go to the screen again. Okay. So that was question number 1A to question number 6A. The B1 is 66 and 72. Okay. So let us find the LCM of 66 and 72. So let us go for this 66 and 72, right? 66 and 72. This is the B part. Now again, 66 and 72, I'm going to write this way, long division method, right? And I'm going to put this L bracket. Now 66, 72 both are divisible by 2. So I'll start with the 2. Now 66 divided by 2 happens to be 33 and 72 divided by 2 happens to be 36. Okay. Then again, check whether 2 is dividing any of the number. So 36 is being divided by 2, 33 not. So, but I'll take 32 and here I'm going to write 33 itself because it is not divisible by 2 exactly. And 36 divided by 2 is 18. So I'll write 18 over here. Again, I'll go for 2. I'll write here 33. Here I'll write here 9 because 9 2s are 18. Now you can see 33 as well as 9 both are not divisible by 2. So I'll have to stop dividing by 2. Now I'll start with 3. 3 11 times is 33 and 3 times is 9. Again I'll go by 3. 11 is not divisible by 3, so I'll put 11 itself over here, and this 3 is divisible by 1. Okay, 3 is divisible by 3, and you'll get 1 over here. Now you are left with only 11 and 1, so take 11 and you'll write a 1 over here, 1 over here. So you have to go on doing this till you get 1, 1 in the bottom bracket. Okay. So the LCM happens to be the product of all these numbers. So 2 you have 3 times, so I'll take 2 raised to 3. 3 I have 2 times, so I'll write 3 raised to 2 and 11. This works out to 2 cube as 8, 3 square as 9, and this is 11. So 8 into 9 is 9, it's a 72 into 11. So the answer will be 72 into 10 is 720 plus a 72 will be 2, 9 and 7. So 792 is the LCM of these two numbers, 66 and 72. Right. So that was long division method. Now let us try by uh, prime factorization method. Okay. 66 and 72. Fine. 66 divided by 2 will be 33. Okay, 33 is not divisible by 2, so I'll go for 3. And 3 into 11 is 33. 11 being a prime number, it will be 11 into 1. That's it. Once you get 1 over here, these are the prime factors of 66. That is 2 into 3 into 11. Now go for 72. Start with the 2, 36, 2, 18, 2, 9, 3, 3, 3, 1. Once you get 1 over here, these are the prime factors of 72. You can write it as 2, 1, 2, 3 times. So 2 raised to 3 and 3 2 times. So 3 square. Okay. Once you get the prime factors of these two, 66 and 72, now you take the common factors one by one. So 2. The highest power of 2 is here, 2 raised to 3. So LCM may I'll take 2 raised to 3, not this 2 raised to 1. Then 3 may, you have 3 raised to 1 in this and you have 3 raised to 2 in this. So I'll take 3 raised to 2. The highest power uh, common you have to take. Okay, so 3 raised to 2 I'll take instead of 3 raised to 1. And then whatever is uncommon, that also you have to take. So uncommon is just 11. So that also I'm taking. Now this works out to 2 raised to 3, 8. 3 squared 9 into 11. This is 8 9s are 72. 72 into 11. And 72 into 11 works out to 2 7 2 7 2 9 7 792. So this is the LCM 792. So by this method also you are getting 792. This is prime factorization method. And by this method also you are getting 792. This is long division method. Now I'll show you on GDC. Okay, so I'll take you to my document camera and show you how you can do it on GDC. So here you are on the GDC. So again, I'll on my Igcse. Yeah. Now I'm already on new. So I'll go for OK. And add calculator, I'll go for OK. And I'm on the calculation page. So as usual, I'm going to type LCM. LCM. And you can see you are getting that LCM over here. Then parenthesis, right? And the numbers were 66, comma 72, right? 66 comma 72. Close the parenthesis and just enter. See, you are getting the answer over here. Can you see the answer? 792. So the LCM of 66 and 72 happens to be 792. This is using the GDC. Is that clear? So I suppose you must have got a knack of finding the LCM by manual method also. Two methods I have taught you. And I have taught you using the GDC also. Isn't it? Right? Chalo. So let us go for the next one. And next one is this one. Okay. It's a 2 square 3 cube 11. And okay, let me do full screen first. Yeah. Now here, the C part of the question is very easy. We can do it here only, C part. Okay. Now these are the two numbers, 2 square, 3 cube 11 and 2 cube 3 and 5 square. Okay. Now these are already in the prime factor form. Okay. The two numbers are in the form of the product of prime factors. Okay. So what you have to do from this 2, you have to take one by one the common ones. So first common will be, so LCM will be, first common is 2. Now here you have 2 square, here you have 2 cube. So you are going to take 2 cube. Out of 2 square, 2 cube, you will have to take the one which is having highest power, higher power. So I'll take 2 raised to 3. Then I'll go for 3. In 3, I have 3 raised to 1 over here. I have 3 raised to 3 over here. So I'll take 3 raised to 3 and not 3 raised to 1. The one with the higher power you have to take. Okay. Then you can see now the common are over. Like you don't find any common number in this 2. So you'll go for the uncommon ones. So uncommon may you have a 5 square, so that you will take, and you have 11, so that you will take. So your LCM happens to be 2 cube, that is 8, and 3 cube, that is 3 3 9 3 27, 5 square, that is 25, and then 11. Okay. So if you multiply out all this, you will get the LCM. So 8 into 27 into 25 into 11. This is what I will have to find out. So I'm using my Igcse and I'm doing that on my Igcse, but I'm not showing you. So 8 into there's a 27, right? Into there's a 25, right? And into there's 11, right? So 8 into 27 into 25 into 11 is equal to 59400. So this works out to 59400. And this happens to be the LCM of these two numbers. Okay, which are already in the prime factorization or in the prime factors form. Okay, so this is how you have to do the LCM part of this question. That was question number 6. Okay, now coming to question number 7. Question number 7 says that the product of two numbers is equal to HCF of two numbers multiplied by something. So answer should be what, there's a law which says that product of any two numbers is always equal to the product of their HCF and the product of their LCM. So here you have the statement says product of two numbers equal to HCF of two numbers is given. So here you will have to write LCM of the two numbers. So this is the answer. Okay. Now B part of this question is, if 120 and 504 are two numbers given, then show that what you have to show that A is satisfied for these two numbers. A means this particular law is satisfied for these two numbers. So for this, what I will do, the law says that the product of two numbers, that is 120 into 504. This should be, now I'll put a question mark because I want to check it whether it is correct or not, whether it is satisfying or not. So the law says the product of the two numbers, that is 120 into 504, should be equal to the LCM of the two numbers, LCM of the two numbers into HCF of the two numbers, isn't it? Now, what is the LCM of these two numbers and what is the HCF of these two numbers? Let us try to find out that. So again, we'll go to our GDC and try to find out from that what is the LCM and GDC of 120 and 504, right? So here we go on the document camera. Now we are already on the screen. Okay. So LCM, now this comes in an italic form. Okay, it's okay, not an issue. LCM of 504 and what was the other number? 120, right? Right. So I have typed in LCM parenthesis 504 comma 120, close the parenthesis, and now I am going to press enter. So I'm getting the answer as 2520. So LCM I am getting as 2520. So let me write that LCM of the two numbers as 2520, right? So this I'll write as 2520. What will be HCF? For HCF, again I'll go to the GDC, okay, and I'll show you how to find out HCF. For HCF, you don't type in HCF over here. For this particular TI Inspire, what you have to do is you have to type in GDC, okay. So here we go, GDC. Okay. HCF doesn't work over here. GDC and HCF, by the way, are both one and the same. HCF is highest common factor. GDC is greatest. Uh, is it GDC? Yeah, GDC. Yeah, GDC of 504, comma 120. Okay, let us check out and enter. Right now, GDC. Oh, I'm getting a error because I've yeah, I got it. Why I got error? It's not GDC. It's GCD. Okay, so I'll go for GCD, greatest common factor, right? So GCD, okay, parenthesis 504, comma 120, close the parenthesis and just enter. Yeah, see GCD we are getting as 24, right? So I'll go back and write HCF as 24. So this HCF will be 24. Now 2520 into 24 should be equal to the product of this. Okay, if this is satisfying, then we can say that this rule A is being satisfied. Okay, we want to show that, no? So chalo, let us do that. Now I'll do this way. I'll do here on the calculator, but I'm not showing it to you. 120 times 504. 120 times 504 works out to 60480. So this part I'm getting as 60480. Right? Now let us check whether this is equal to. So 60480. Here this is 2520 times 24. Enter. So I'm getting the same thing, 604 and then 80. Okay, I'll put a tick mark over here. So you can see that on putting the values of the two numbers, finding the product of the two numbers, I'm getting 60480, and finding the product of their LCM and HCF, that is 2520 and 24, again I'm getting 60480. That means this particular law, that is product of two numbers, is equal to the HCF of the two numbers times the LCM of the two numbers, is true. It works. Okay. So question number 7 is done with. Let us go for question number 8. Question number 8 says that what is the LCM of 60, 75 and 90, and what is the HCF of 48, 84 and 132. Okay. So one by one, let us now, these are three numbers. Okay. So let us see how you have to deal with these three numbers. So first I will find out the LCM of 60, 75 and 90. 60, 75 and 90. Now again, you will have to use the same two methods. So 60, 75 and 90 I have written here. L bracket I have put. And I can see that minimum 2 is something that divides at least one of the number. So I'll start with the 2. So 2 into 30 is 60. 2 doesn't divide 75. So I'm going to write 75 as it is. 2 into 45 is 90. So I'll write 45 over here. Next, 2. 2 into 15 is 30. 75 is not divisible by 2, so I'm going to write 75 as it is. 45 is not divisible by 2, so I'm going to write 45 as it is. Then can we come to 3? Yes, 3. Now 3, 5s are 15, 3 into 25 is 75, and 3 into how much is 45? 3 into 15 is 45, right? Then again 3, yes, again 3 will go. 3 doesn't divide 5, so I'm writing 5 here. 3 doesn't divide 25, so I'm writing 25 here. But 3 does divide 15, so I'm writing 5 here. 3 into 5 is 15. Now I can see 3 is not dividing any of this, so I'll go for 5. Now 5 1s are 5, 5 5s are 25, 5 1s are 5 again. And you can see that there's one 5 over here. So once again I'll take 5. This one I'll repeat here. This 5 I'll write here 1, 5 1s are 5, and this one I'll keep it here. So see, at the end I'm getting 1 1 1 in the last L bracket. So my LCM will be the product of all these numbers from here to here. So it will be 2 square into 3 square into 5 square. That is 4 into 9 into 25. Now 9 fours is 36 into 25. And 36 into 25 happens to be uh, 900. Okay. So the LCM of these three numbers is 900. This is by long division method. Now if you want to do by prime factorization method, you'll have to first find out the prime factors. Okay. So 60 ka prime factors start with 2, 30, 2, 15, 3, 5, 5, 1. I hope you must have understood. Now this I'll write as 2 square into 3 into 5. Right. Now 75, it is not divisible by 2. So I'm starting with 3. 3 into 25 is 75. Then 3 doesn't go. 5. 5 into 5 is 25. Then 5 into 1. Okay. So you get a 1 over here. So this will be 3 into 5 raised to 2. Now for 90, I'll start with 2. I'll write here 45. Now I'll go for 3, 15. Then I'll go for 3, 5. Then I'll go to 5 and 1. Right? So the prime factors that I'm getting is 2 into 3 is 2 times. So 3 square into 5. Okay. So these are the prime factors of 60, 75, 90. Now LCM will be, you'll have to take one by one. So this is 2 square over here. Do you have 2 square over here? No. You have a 2 over here. Okay. So 2 is not common, right? 2 is not common. So we'll go for 3. 3 is common. Yeah. Here you have a 3. Here you have a 3. Here you have a 3 square. So I'll have to take 3 square. The highest one, the one with the highest power you have to take. Okay. So 3 square I have taken. So 3 is done. Now 5, let me check. You have 5 raised to 1 over here. You have 5 raised to 2 over here. You have 5 raised to 1 over here. So I'll take 5 raised to 2. Right. So the common ones I have taken. Now what is uncommon left out? Uncommon left out is 2 square from here and 2 from here. Okay, I think now all is covered. So let us work out this. 3 square 9, 5 square 25, 2 square is 4 and this is 2. So this has to be the LCM. This is 4 2s are 8, 8 9s are 72, 72 into 25. So 72 into 25 is how much? Let us check. 72 times 25. Enter. Oh, it's 1800. Yeah. Here I made a mistake. This 2 I should not take. Okay. From this 2, I should not take this 2 raised to 1. So I should take only 2 square. The one with the highest power you have to take, isn't it? So 2 square I will take, not the 2. So this 2 I will have to remove. Okay. So you'll be left with this. 9 into 25 into 4. Now let us check what is the answer. 9 into 25 into 4. It should be, yeah. 9 into 25 into 4, right? Yeah, enter, and I'm getting a 900. Yeah, so 9 into 25 into 4 is 900. So the answer happens to be 900, isn't it? Yeah, okay. So by both the methods, we are getting the answer as 900. Now the question arises, how are you going to find the LCM of three numbers on a GDC? So for that, what you have to do is, I'll take you to GDC. Yeah. Now, I'm sorry. Uh, 1 second. I'll have to bring back the OneNote. Yeah. So we were doing which question? Yeah, it was this one, right? Uh, 60, 75, 90, isn't it? So 60, 75, 90, if you want to do on GDC, what you have to do is first you find the LCM of 60 and 75, and whatever answer you get, that you take along with 90 and find the LCM. What I'll do is here again I will type in LCM, okay, of 60 and 75. So I'll put 60 comma 75, isn't it? And parenthesis close and enter. So for 60 and 75, the answer I'm getting is 300. Now what I'll do, again I'll find the LCM of this time I'm going to find the LCM of this 300, and the third number was 90. So I'll have to take that 90. So 390 and parenthesis close and just enter. Can you see the answer I'm getting is 900. So on GDC, if there are three numbers, you have to first find the LCM of the two numbers, any two numbers. Whatever answer you get for that LCM, okay, that number you have to take with the third number and again find the LCM. Okay. So this is the way how you have to work with a GDC if you want to find out the LCM of three numbers. For GCD also you have to follow the same method. You have to take first two numbers, find the GCD, and then they take the answer for that and the other number you take together and find the GCD. Okay, so that's how you have to deal with this question number. Uh, this was which one? This was question number 8, the A part. Okay, now question number 8, B part is find the HCF of 48, 84, and 132. Okay, 48, 84, and 132. Now this one I'm going to show you first by 48, 84, and is it 132? Yes, check it. Yeah, 132, 48, 84, and 132. Fine. Now here, what you can do is, here also we have two methods. Okay, I'll teach you two methods. One is the division method, not long division method, division method. So in division method, what you have to do is, you first take uh, any two numbers, okay, in order. Okay, suppose you take the lowest one and this one, okay, 48 and 84. Then what you do, you write this way. The bigger number you write inside and the smaller number is the divisor. Okay, so basically 84 you are dividing by 48, and here you put like this a bracket or whatever it is, and now do the division. So 48 into how much is 84? So just try to find out that. So 48 into 2 will be how much? It will be 96, right? So 48 into 2 itself is going more than 84. So I'll take just 1 and I'll write here 48 into 1 is 48. Then I'll subtract. Now 14 minus 8 is 6, and this is 7 minus 4 is 3. I'm getting remainder as 36. Now what I'll do is, this remainder 36 I will put inside, and this divisor, uh, sorry, this 36, one second. Yeah. Okay. So now what I'll do is, this 36, I will keep out and I'll put this 48 over here, right? The previous divisor I'll put inside. Okay. Now this remainder that I got in the first step, 36, that is the divisor, and the previous divisor is now the dividend. So 36 into again 1 will be 36, isn't it? And the remainder will be 8 minus 6 is 2, and 4 minus 3 is 1, so 12, right? Now again what I'll do, this 12 I will keep outside and I'll take this divisor 36 inside this way. Now 12 into 3 is 36, and now I am getting the remainder as 0. So this is the way you have to go on dividing the two consecutive numbers, okay, smaller and the bigger one, and go on dividing it till you get a remainder as 0. The last divisor is supposed to be the HCF of this two number. And which is the last divisor? See, this 3 is not the divisor, okay, 3 is the quotient. This 12 is the last divisor, okay. This was the first divisor, this is the second divisor, this is the last divisor which gave you 0 as the remainder. So HCF of these two, that is 48 and 84, is nothing but 12. Now we have the third number also, 132. So now what you have to do, the bigger number 132 you take inside, and this 12 you take, which is the HCF of these two, okay, and repeat that division method. Okay, so 12 and 132. 12 is the divisor, 132 is the dividend. Now 12 into 1, no, you'll have to take the entire number, okay, in one go. So 12 into 10 will be 120. 12 into 11 will be how much? 12 into 11 will be 120 plus 12, right? 120 plus 12. That happens to be 132. Yeah. So 11. 12 into 11 is nothing but 132. And you are getting this as 0. Remainder is 0. Now, here in one go only you got the remainder 0. So the divisor, the first divisor itself is your HCF. So this now, this 12 is the HCF of all the three numbers, that is 48, 84 and 72. Okay. So 12 is the HCF, the answer for this. Now this question, same question, we'll do by prime factorization method. So 48, 2, 24, right? 2, 12, 2, 6, 2, 3, 3, 1. So the prime factors will be 2, 1, 2, 3, 4, 2 raised to 4 times 3. Now let us go for 84. 84 will be 2, 20, 42, 2, 21, 3, 7, 7 and then 1. Got it? So 2 how many times? 2 times. So 2 square, 3 ones, 7 ones. These are the prime factors of 84. Third one is 132. Start with the 2. 2 6 are 12. 1, 2, 6 are. So 66, right? Again 2, 33. Now 33 doesn't go by 2, so I'll go by 3, 11, 11 and then 1. So the prime factors are 2 square into 3 into 11. Fine. Now HCF of these three numbers will be, you take only the common ones. Now you have to not take the uncommon ones, okay? Take only the common ones. So first you go for 2. 2 you can see in all the three. But this time you don't take the higher power, okay? You'll have to take the lowest power. So 2 raised to 4, 2 raised to 2 and 2 raised to 3. In this 2 raised to 2 is the one which you have to take. 2 raised to 2. So 2 is done. Now 3. 3 you can see here also, you can see here also, you can see here also. And all the powers are same, 1, 1, 1. So just take that 3 raised to 1. There's no question of which is higher power, which is lower power. All are having the same power 1. So you take that 3. And 7 and 11 you can see as uncommon. But as I told you, for LCM you have to take uncommon. But here you are not supposed to. Isn't it? So this is the HCF. So if you work out, this will be 2 square into 3, that is 4 into 3, 12. So 12 is the HCF of these three numbers. So by this method also you are getting 12 as the HCF. By this method also you are getting 12 as the HCF. This is known as prime factorization method. Okay. So you will see that prime factorization method is there for both LCM and HCF. But then the final stages, what you have to do with those prime factors, that you have to take care. For LCM, there's a different thing. For HCF, there's a different thing that you have to follow. This method is known as division method. just division method. Okay, fine. So both this method I've explained you how to find out the HCF with the division method and prime factorization method. Now the last method that is remaining is GDC method. Okay, so GDC method say let us go for the GDC method. So here you can see your calculator. Okay, okay. So what I'll do is GCD I'll type greatest common divisor. Okay, so GCD. So you got the GCD parenthesis. I'll take any two numbers first. So let me take 48 and 84. 48 comma 84. First I'll find the GCD of these two numbers 48 and 84. So I'll press this enter and I'm getting 12 as the answer. Okay. Now you have a third number also 132. So again what I'll do, I'll type in GCD. Okay. And parenthesis. Now I'll take this 12 which was the HCF of this 48 and 84. That I'll take, and that I'll take along with the third number, and third number was 132, isn't it? 132. Now enter, and you are getting again 12 as the answer. So this final answer 12, okay, that you get, this 12 is the GCD of all the three numbers, that is 48, 84 and 132. So this is the way, this is the method of finding the GCD or the HCF of three numbers using your graphic calculator. Fine. So that was question number 8, I suppose. Okay. And I think 9th and 10th, you know, these two I'll be doing next time because time doesn't permit me and I want to wind up this video here only. So that's all for today. Okay, in the next video we'll be covering this question number 9th and 10th as well. And this video, if you happen to like it, please subscribe my channel. That will help me, that will motivate me to make more such videos. And I'm using now even this GCD with my regular lectures. Okay, so you'll get a knack of everything. Okay, that's it. See you next time. Bye. Take care, all of you.